Hi everyone. Today we have complete course of multithreading in Python. Multithreading in Python allows multiple threads to run concurrently within a single process, improving the efficiency of programs that perform multiple tasks simultaneously. Here are some key points to understand multithreading in Python. What is multithreading in Python? How to create threads? Thread synchronization, while locking, threading events, what is Semaphore, what is Async IO package in Python. With this package, we will closely look at concepts like async and await keywords, creating tasks with Async IO package, exception handling with concurrent execution. So let's get started with all concept of multithreading in Python. First, we will understand what is multithreading. Multithreading is nothing but it is a multitasking. The example of multitasking is to open up a Microsoft Word document and type something at the same time your spelling check and grammar mistakes are getting checked in the backend, right? So this is called a multitasking. What is multi-threading in Python? Multi-threading is a technique in which multiple threads in a process share the same data space with the main thread and they can execute independently but share the same CPU. Threads are lighter than processes and share the same memory space. You can consider a application program which is running on operating system. This is called a process. A process can contain multiple threads. When you open the task manager, you will see there are multiple processes which are getting executed, right? Each process represent a application program. Okay, I have some code handy to save some time to explain more what is multi-threading and how it works in the program. Okay, so this is a simple Python program which actually print number and letters. The first function which prints the numbers from 0 to 9 and the second function which prints letter from A to Z, right? And here we have used a time module to measure the time, how much time those both function has taken. We have start the time and then we have end the time, right? Then we have end time minus start time. In second, how much time it has taken. So you can see the total time, how much they have taken. And these both functions are getting executed in a sequence, right? First this executed, after that this function executed, right? Which means when this function was getting executed, the cursor was waiting here only, right? Once this executes, after that this start executing this another function, this function, which means most of the time CPU was idle and we could have used the CPU idle timings, right? In order to use the maximum time of CPU, we can use multithreading in Python. Okay, let's implement multithreading. Okay, so in order to achieve multithreading, so we have to import threading module. Instead of executing this function directly, we have to assign these function to the thread, right? Okay, so we will be creating thread1 t1 equals to threading dot thread target argument, which refers a function, right? So we are going to refer our any of the function, right? In the same way, we are going to create another thread t2, and in this t2 thread we are now referring another function, that is write letters. So this is how we can refer our function into threads, and this thread would be starting. I'm going to remove this function which was executing directly. Now we have to wait till this execution gets over, right? So with the help of join function, we will wait here, right? t2 dot join. Okay, so this is the only thing we have to do, and other statement of the program as it is, right? Okay, now we have shifted our execution of both the function into the threads, and these threads will be starting and then they will be joining, right? Okay, if you run the program again, so you will see time would be very less this time. You see, even you see the output of each function was mixed in the execution, right? 0 A 1 B 2 C 3, right? So this is how we utilize the CPU timing, and at the same time both function got executed. While with the previous program, both two functions, these two functions were getting in a sequence, right? One after another. Okay, so this is how we can use multi-threading in Python. What is thread synchronization and how it will work with multiple threads. In multithreading, when multiple threads are working simultaneously on a shared resource like a file, then to avoid concurrent modification errors, we have to use some locking mechanism where one thread is accessing a resource, it takes a lock on that resource, and until it releases that lock, no other thread can access the same resource. I am using editor PyCharm and Python version 3.12 is installed on my computer. I have very simple program with me to save some time, and I will explain how we will understand thread synchronization and how we will use locking mechanism. Okay, this is a very simple program. We have one class, we have used constructor wherein we have defined a instance variable which will contain a counter value, right? In the same class, we have one increment function which will actually increment this counter value, right? Try and finally we have used to just avoid any error at the runtime. Okay. After this, we have a task function which will be running 3 times and it will be calling the increment function of this class. 3 times it will call. Okay. And after that, we have created a object of the shared counter class and we created a new thread, right? We have assigned a name, okay, to this thread and we have refer a task. This is a function. Okay, this is outside of this class, right? So this task function we have refer here in this thread and we have passed this s counter class object as an argument for this thread. Okay, that argument comes here as a c and this c dot increment would be called up. Okay, so it will show you the increment value each time when it executes the increment function, right? So 3 times it will show you the output. Okay, then we have start the thread, then we have waited to join the main thread. Okay, this is a very simple program to understand first what we are going to do. Okay, then we will implement the main concept of thread synchronization. If you run the program, so you will see the output, that is the T1 thread which we have initialized as a name, and the counter value is 1 2 3 because each time we are incrementing this counter value on this class instance. Okay, so it ran 3 times because we have defined this is r equals to 3, right? So 3 times this increment function got executed and it printed the value, okay, this counter value each time, right? 3 times. This is very simple program. Now we are going to see how thread synchronization works. Okay. So what we are going to do, we are going to first create one more thread, right? That is T2, right? Because we have to see how a shared resource can be protected, right? Just name it T2, okay, and the same task we are going to execute, it means it will execute 6 times. Okay, t2 dot start and then t2 dot join. Okay, these are two threads now which will execute this task function. Okay, and this task function will execute increment from this class, right? So I am going to say self dot lock one lock instance class instance I'm going to take here, and then I'll be using threading dot log. And then before incrementing value of this class instance, we are going to acquire a log dot acquire. Okay, this is very simple statement we have to use, and once our counter is printed, we have to release this log. What this function ensures, so this acquire function will ensure no other thread at the same time is going to access this instance variable. Okay, and this release function will ensure after printing the class instance value, it will release the log. So this is the very simple concept here to actually protect your shared resource among multiple threads. Okay, if you run the program again, so you will see here output, there are 6 statements which are printed on output window, 1 2 3 4 5 6, and our counter is 6 here from this. So this is how thread synchronization works with locking mechanism. We can access shared resource among multiple threads. So Python file locking is a technique which is used to control access to a file by multiple process or threads. Here we will ensure that only one process or thread can access the file at any given time, preventing conflicts and data corruption. Python supports file handling and allow users to handle files, that is to write and read files. So I have very simple program which is actually writing some text on a physical file. Okay, so I have one file, threading log.txt file at the same location from where this program is running. So this is a blank file if you see. Okay, if you check this program, here we have one simple function write file which is opening up a file and applying a mode which is for writing, and we are writing this text into this file. Okay, and this function we are calling at the bottom, and we are printing on the output file is updated. If you run the program, file is updated is shown, and if you check the file, so file is now written. Python is a programming language. The main thread from where this program is running is actually writing this file. Now, if we talk about multiple threads, how we can share this file among multiple threads and how we can write some text by each thread. Now, next step, to create multiple threads which will be writing this shared file. Okay, I have some code snippet to save some time where we are creating list of threads, right? We are iterating 15 times here and we are creating threads, right? You see, so on this list of threads we are appending our new thread. We need a threading module, import threading, right? Here what we are doing, we are creating new thread each time, and we are appending this new thread to this list of thread object, and we are also starting the thread immediately, right? Here we are referring the same function write function to write some data right inside, and we are also sending one argument. You can send some argument also, thread number you can pass on here and say thread I, right? Let me remove the code from here, paste here. So it is the same program as we were doing, but the difference is we are now using multiple threads. 15 threads would be opened up and they would be starting immediately, right? We are waiting until all threads are completed. Okay, in for each we are using join function to complete all threads at least. Okay, if you run the program again, so you will see your file, so it will show you like 0 2 10 9 5. These are the thread numbers which we have passed on in the write file method. Okay, but if you notice, we had created 15 threads, but here you could see only 9 threads. This is because at the same time threads are trying to write this same resource file. So this is the problem which we are going to resolve. With help of locking technique here, we will make our these file physical file thread safe, right? So what we are going to do here, we have to just say lock, we can say threading dot lock. Threading dot lock we are going to use, and we have to just say with lock. Before writing any of the file by any of the thread, this code is logged. Okay, this is the only thing we have to do here to make our resource thread safe, right? Now if you run the program and you see the output, so you will see all your 15 threads are able to write this file, right? You see, all 15 threads were executed. This is the benefit of locking technique with multiple threads which are trying to access same shared resource, right? Guys, in this video, you will learn how to use Python threading event object to communicate between threads. Sometimes you need to communicate between the threads. To do that, you can use a lock, mutex, and a boolean variable. However, Python provides you with a better way to communicate between threads using the event class from the threading module. What is event class? Event class offers a simple but effective way to communicate between threads. One thread signals an event while other threads wait for it. I have a very simple program to explain you things in better way. This is a threading module, right? I have imported thread class. Okay, I have taken a task which is actually printing a statement thread is start. Okay, After that, I have created two threads, different threads, which is referring this task function. Okay. Along with it is passing an argument to this task. This is thread ID. Okay. After that, we have started both threads and we have just waited to finish both tasks with help of join function. If you run the program, so it will show you thread 1 is started, thread 2 is started, right? These two threads are independent and we have just printed a simple statement, okay, inside. Now, our agenda to understand how we can pass signals from one thread to another thread. Okay, now I have a better version of this function. If you see, we are using event, right? So event, how we can get event class, we can refer here. Okay, and we are using time as well. Here we can see clearly this is a same task that we were referring in a previous program. We have used event here, right? We have passed this event as an reference, okay, in this task through the thread, right? In the thread, we have passed event and this event object is created with this event class. This is nothing but it's a threading event class which actually manages the flag that can be set to true with the set method and reset to false with the clear method. The wait method blocks until the flag is true. The flag is initially false. Okay. So with help of wait, we are now blocking the execution. Okay. Until and unless we set is to true. Okay. So what we are doing here in both the threads, we are passing this event, right? And this event actually it is used to pass the signal. Okay, if you look at here, we have now put our main thread on sleep for 2 seconds and then passing the signal to the event that you can resume the execution further. Okay, because both the threads are referring the same task. If you're in the program again, so you will see a delay of 2 seconds and then we receive the signal, right? This way. Okay, if you still are not able to understand it, I have another way to make you understand. I have one function with me, right? So what we are doing here, we are trying to write a file on the same location from where we are running this program. We are iterating 10 times and 10 times we are writing some content into the file in this file. Another task is to create another function which will count the total number of words. These are two different tasks which will be performing on the same file. Event we have used to just check whether we have to wait or we have to resume the execution, right? We have taken word count, we have opened the file in the read mode, then we are iterating the file content from this object and we are splitting each line, right? After splitting, we are counting the length of the words, right? And then we are aggregating the value in this word count variable, okay? And then we are printing it. And what is next step? Next step is to create an event object from this event class, and we have to create two different threads, thread 1 and thread 2. Here we are referring both the function, right? Thread 1 we are referring write file, which will be writing the content into the file, and in the second thread we are referring count words. Okay, both the thread would be starting at the same time, right? And they will be waited for here until they are completed. After writing the content into the file, we are sending the signal through this event object to this different thread. Okay, you can now open up the file and start counting the words. If you run the program, you will see the difference. You see, we are writing the content. Once the content writing is completed, then we are starting the counting of words. See, there are 60 words. If you open up the file, if you input more words here and then start the program again, so you will see again it will write the same content inside the file, right? And then it will count the number of words in the file. I hope it will clear you the concept of threading events in Python. Guys, in this video, we will learn how to use Python Semaphore to control the number of threads that can access a shared resource simultaneously. A Python semaphore is a synchronization primitive that allows you to control access to a shared resource. Basically, a semaphore is a counter associated with a lock that limits the number of threads that can access a shared resource simultaneously. A semaphore maintains a count When a thread wants to access the shared resource, the semaphore checks the count. A semaphore has two main operations: acquire operation and release operation. So now let's see how we can implement semaphore in our Python program. Before moving further, I wanted to show you there is a one location on my computer screen wherein I have five files: invoice 1, 2, 3, 4, 5, right? So we have just entered one text basis on countries US invoice. Similarly, in the second file, we have entered UK invoice. Okay, so all five files have some words, and these file we are going to read from this location in our Python program. You can consider this location might be a shared location on the network, right? Let me minimize this. I'm using editor PyCharm and Python version 3.12 is installed on my computer. First, you have to import threading namespace, okay, and then you have to create a object semaphore. So we can limit our threads here by specifying a number. I want to say 3. Only 3 threads can access my shared resource at a time, right? So this is the second step. Now we have to use the semaphore object. We have to use both operation release and acquire, which we have already seen in our previous examples. Okay. So first what we have to do, we have to read our old files right from that location. I have some code handy to save some time. This is a simple function read invoice, which will be having a file name from the thread. We will be opening these files, okay, from this input output operation open function, and then we are going to read the file, and then we have to print the file content on the console, right? So we will be mentioning which thread is accessing this file and what data we have now retrieved from the file. This we are going to print, right? This is string format we have used. Let's say if you want to execute this function, so I'm saying 1 and I'm saying invoice 1.txt, right? If you run the program, so you will see US invoice. This text is written. However, we have not created any of the thread yet. Neither we have used semaphore object, right? I wanted to show you how this function works. Okay. So in the same way, we are going to read all the files, but with the help of semaphore, with the help of threadings. I have some more statement ready to save some more time, right? So what I have done here, I have created five threads, right? Thread 1, thread 2, thread 3, thread 4, thread 5, right? Each thread is referring the read invoice function, which is accepting these arguments I, which means thread ID we have passed here. Anything you have you can pass here just to identify which thread is running, and another argument is that is invoice.txt, right? Means we have mentioned the file name, each file name: invoice 1, invoice 2, invoice 3, invoice 4, invoice 5. So all five invoices text files would be open up, and they would be read out and they would be printed on the console, right? If you're in the program, so all your thread would be running, and then they will be printing the data like 1, 2, 3, 4, 5. Okay, right? So these are five files, but we have not yet implemented semaphore here, right? To make sure whether your resource is safe, you have to protect your resource with help of this semaphore object. Okay, so you have to use semaphore dot acquire, you have to use, and as soon as the file is read, you have to release. Okay, if you run the program now, so there is no impact on the output, right? Output would be still same, but here we have ensured how we are going to say only three threads at a time would be open up the file and they would be reading the content. If you don't want to use acquire and release, so you can use with. Okay, so with semaphore, right? So this statement will itself take a log and release the log. Okay, so with the help of with keyword, you can do the same thing. You can perform both operation. Okay, release and acquire both. If you're in the programs, so the output would be the same. Okay, another way, if you don't want to retain this much of code in the thread, there is other way as well. You just take a thread list object, then you start one range that will run 1 to 6, which means it will run 5 times. It would be creating 5 thread, right? And it would be appending the thread into the list of thread object. And from here, you would be passing thread ID and the invoice 123 would be passing like this. And you will wait all threads are completed and then you will join the main thread, right? If you're in the program, so output would be still same, right? 2 times it will, because first this block would be executed, second this block. So that's why 10 times we have read the file. This is another way of doing runtime threading, right? I hope you are now clear with the concept of semaphore, which means you can control the number of threads that can access a shared resource simultaneously. Okay, guys, in this video, we will learn async IO in Python. Async IO, asynchronous input output, is a powerful feature in Python that allows you to write concurrent and synchronous code. It is not multi-threading or multiprocessing. In Python, async IO is supported via the async IO package. Okay, the async keyword defines a coroutine which can use await, yield, or return. The await keyword is used to wait for asynchronous operation. It is used for high performance network servers, web servers, database connection, and many more things. Okay. And how to set up async IO? So you will need Python 3.7 or above. Now let's get started with our tutorial. I am using editor PyCharm and Python version 3.12 is installed on my computer. So in order to start with Async IO package, you have to install it on your computer first. To install Async IO package on your computer, you have to open your terminal. First, you have to check whether Async IO is installed on your computer or not. You have to type in one command, pip list, right? So this command will show you what packages are installed on your computer. If I check, so I could found Async IO is installed on my computer. 3.4.3 version is installed, right? If you want to install Async IO on your computer, you have to type in one command, that is pip install async IO, right? Always latest version would be installed on your computer. Okay, first let's import async IO. Async IO, you could see, right? So we are going to create a simple function, a def function one, and then we will be using await async IO dot sleep for 1 second. Again, we will wait. Okay, and in order to make this function as a task, you have to use async keyword, right? Okay, so this is very simple function. In order to execute this one, async IO dot run function we have to use, and we have to pass on our function one. Okay, this is very simple. If you're in the program, you will see a 1 second of delay in each statement, right? Coding news today, right? Because this silly function works for 1 second. Now let's improve this program a bit, right? We will create another function. So what we are going to do, we are going to execute F1 function inside F2. Okay, io.sleep for 1 second, and then we will be calling await F1, right? So this F1 function actually will be called inside F2, and cursor will be waiting here until this F1 execution is completed, right? Okay, and then we will be printing, let's say, 5, and we will just improve this F1 function 1. Okay, so this is very simple. We will keep everything else as it is, right? If you're in the program again, so you will see a 1 second of delay in each statement 1 to 3. Instead of F1, we will call F2 because inside F2 we have used F1. Okay. If you're in the program again, so you will see 4 is printed 1, 2, 3, and then 5. Okay. You see? So this is how await and async works. We can use these keywords to put our task concurrently. This is not multi-threading and multiprocessing. This is a complete library which actually allow developers to execute program concurrently. Okay. Now let's improve this program a bit. We will be now using async io dot create task function, right? So instead of print o, okay, so we will be just removing this, and before that, what we'll do, we will be creating a task, right? A simple object name we have taken here, async io dot create task function.
Okay, very simple. So if you run the program, so you will see 4, 1, 2, and 3 and 5, right? Means all the tasks are executing concurrently. You can remove this statement, right? And 4152 means 4, 1, but 3 did not execute it. 3 did not print it because this main function is only sleeping for 1 second. If you make it 2, then at the same times other sleep statement would be completing. Okay, you will see 4, 1, 2, 5, 3. Okay, we can use easily create task function. We can create n number of tasks here. Okay, create one more task, take one more task, task 1 and F3. Okay, if you're in the program, here we can increase the sleeping time, and we would see all the statements would be printed, right? 4, 1, 6, 2, 7, 3, 8, 5, right? Okay, right? So this is how we can create n number of tasks with the help of create task function, and we can execute those all tasks concurrently, right? I have bit improved version of this tutorial. We have three functions, F1, F2, F3, right? Wherein we are having one main function. Inside the main function, we are using new function here, gather, and we are calling F1, F2, and F3 from this function. You see, and we are awaiting here until the execution is completed. Here we will wait, okay, and then we will be printing main and it, right? It is very simple, okay, right? If you're in the program again, you will see F1, F2, F3 started, and these all tasks are ended. Guys, so far we have covered different topics on multi-threading. First, we will discuss async IO.create task function. Then we will see how we can handle exceptions with concurrent execution. Right? I'm using editor PyCharm and Python version 3.12 is installed on my computer. First, we will see how to use async IO.create task function. If you have not installed asyncio library on your computer, you have to type in one command pip install asyncio, right? Once this package is installed on your computer, you can start using this package, right? Before starting with anything, you have to just import asyncio. I'm gonna create new function async. We'll just print it, right? Just to check on the console whether text is properly printing, and then we will be using sleep function from asyncio, right? Another function we are going to create, that is async def, we can say main, or we can create a new task with the help of asyncio. This is very simple task, and I'm gonna use this send, and I'll be passing very simple message, okay, await d1. This way we can use it, okay, very simple. And with help of asyncio dot run, right, this function we are going to use to execute our main function. If you run the program, so you will see a message would be printed, message sent on mobile, right? It is clear we had created a task, right? And that task which was executed with help of await keyword like this. So that is what I wanted to show you. We can refer any of the simple Python function in this create task function. You can create n number of Python function and you can refer, right? If you want to create another function like this, so instead of send message on mobile, we can say send message on email, and we can create another task like this, right? That would be T2 for us. Okay, we can here mention send a message on email, right? And we can change the message sent on. In the same way, we can execute this function, right? Okay, when you run this program, so you will see both the messages, both the tasks would be executing, and we will see the message on console, right? So far it is clear, but here the thing, if you notice, we are waiting, right, until our first task is completed, right? We are executing our first task, then once it is completed, then we are saying just execute our next task. There might be a case, first you wanted to send a message on mobile. Once this execution is completed, then only you want to send an email. Okay, so this is a scenario where most of the developers face the issue. I have another point here. Instead of doing this, if you want to make your task parallel, right, at the same times you fire both the tasks, so you can do in a different way with help of await. You can say asyncio dot gather function we can use, right, because it will give you aggregate result for both the tasks, right? So we can mention T1 and then we can mention T2. Okay. So this is another way to execute both tasks parallelly, not one after another, right? If you're in the program, so your both tasks would be executing on the same time. Okay. Now let's see our next point, that is how to handle exceptions while executing concurrent task. Okay. I have some code handy to save some time. Okay. So let me paste it. It is very simple program. You would see a task we have just created, printing, right? That will actually accept two parameters, task and text, right? So task name we will be assigning from the caller function, and then text we will be printing which we want to see on the console, right? So it will print first, it will keep running until this condition is true, right? We have used try exception, right? Where we have used sleep. Once the time is over, then we are going to cancel this task, right? This way. And in the different function, main function, we have used try and exception block here, and we have used asyncio dot wait for function. So coroutine will be wrapped in the task. So these are the coroutines, and these are wrapped into the task. Asyncio dot gather we have used inside this wait for. In the gather function, we have passed two tasks. That task name is different for each, and the message is also different. Okay. So here what will happen? So this task will keep running till this seconds. Once this time is over, then it will cancel the task, right? And it will come out here and then say time is over. Okay. If you're in the program, so you will see message keep running in a loop, and now once the time is over, these seconds are over, then our this task is cancelled. What is to? It means loop, call later, right? Okay. So here it is very simple. Whenever you want to handle the exception and you want to cancel your task, this way you can cancel it out, right? I hope it will clear you the concept of how to create task using asyncio.createTask function and how we can handle exceptions, right?
That brings us to the end of the today's video. We hope you found it informative and engaging. Don't forget to subscribe to our channel for more exciting content on all things tech related. Thanks for watching, and we will see you in the next video.